Welcome back, y'all. In this video, I'll be making Copycat Super Blue and Oxpho Blue, two cold bluing products. I think I'm getting sick, so that's why I might sound different than I usually do. I'm doing this because someone commented asking me to recently, and it made me remember a brief phase I went through of being obsessed with surface finishes. The fixation was in part due to me wanting anything steel in my lab space not to get rusted to shit because of all the acids I work with. It never really went anywhere though, and I just accepted everything getting rusty. Until now, I guess. I'll do a cost analysis at the end of the video to show how much cheaper it is to make the bluing products. What do I need? For super blue, I need copper phosphate, copper nitrate, nitric acid, selenium dioxide, and water. For Oxpho Blue, I need copper sulfate, nickel sulfate, selenium dioxide, phosphoric acid, and water. For all the copper compounds, I'm talking about the copper 2 salts, not the copper 1 salts. I already have copper nitrate and copper sulfate, I have nitric and phosphoric acids, and of course I have water. Copper phosphate is easy to make, and I thought I had selenium metal somewhere, but no, what I was remembering was samarium metal. I ordered metallic selenium from eBay and it arrived when I was working on my last video. I do have nickel chloride and it's easy to make nickel sulfate from that. It's just adding a carbonate salt to the nickel chloride, which precipitates nickel carbonate, filtering that off, washing it, and then dissolving that in sulfuric acid and boiling it down. So what is cold bluing? It's surface treatment for steel. It doesn't work on all steels like it doesn't work on stainless steel, but for like pretty much any standard kind of steel it should work as far as I can tell. This is not my area of expertise. It's basically the formation of selenide salts, in this case mostly copper, but in the Oxpho Blue there's nickel and copper, so I guess it forms nickel and copper selenides. Most people use it for guns, like gun barrels, but I've seen some like restoration channels on YouTube that use it for screws and other stuff, but it's not that durable, relatively speaking. Hot bluing is much more durable, but cold bluing is a lot easier to do at home than having a very hazardous hot bluing setup. First, I'll show part of my failed first attempt to make copper phosphate. I made basic copper carbonate from a solution of copper sulfate by adding a solution of copper carbonate to it. I diluted the calculated amount of phosphoric acid in slight excess with water, heated it, and added the basic copper carbonate in portions, because it evolves CO2. I filtered the precipitated copper phosphate off and stupidly boiled it with water to try and remove impurities, but this ended up converting it into basic copper phosphate. I added phosphoric acid to this until it went back to the color that it was and should have been, but I added too much phosphoric acid and the copper phosphate was reasonably soluble in it, so I boiled it down, which didn't really do much other than make this super cool looking solution. On further trying to reprecipitate the copper phosphate, I was going to grab the beaker with a pair of crucible tongs and then I knocked the fucking thing over, so I started over with a different approach. I made a solution of copper sulfate, slightly contaminated with what I assume is either basic copper sulfate or basic copper carbonate, as can be seen by the cloudiness of the solution. I should have hot filtered the copper sulfate solution when I was recrystallizing it, but oh well. I made a solution of trisodium phosphate by neutralizing a solution of sodium hydroxide with the calculated amount of phosphoric acid in slight excess. I added the TSP solution to the copper sulfate solution, and copper sulfate precipitated. Both solutions were around 70 degrees when I combined them. I waited for it to cool, filtered it, stirred the damp copper phosphate with water, filtered it again, washed the precipitate on the filter with water a few times, and dried it. You'll see the dry copper phosphate when I make the super blue. Next, making selenium dioxide from selenium metal. It's very straightforward. The YouTube channel Poor Man's Chemist did it. Check out his video for a more in-depth version of what I did. It's done by just straight up boiling the metal in nitric acid until everything dissolves that can dissolve. I started with a small amount of selenium, adding it at such a rate that the dissolution didn't get out of control. I used about 75 milliliters of azeotropic nitric acid to start and added like 10 to 15 milliliters later on when the metal stopped dissolving. After this, I filtered the solution through a plug of glass wool to remove the tiny amount of undissolved crap. I don't know what it is. It must be some kind of impurity that's present when you're refining the metal, but there's so little that I didn't care to find out what it was. I set the beaker with the clear solution on a sand bath and let it go until all the liquid evaporated. Once it had, it was getting late, so I put the beaker in this small paint can, which is lined with, I think, like some kind of enamel, so I'm not worried about rust if there's any acid present in it, to cool and protect it from dust and atmospheric water vapor. The next step, sublimation, serves two purposes. One, to thermally decompose any selenic acid formed into selenous acid, releasing oxygen and then further dehydrating that into selenium dioxide, which gives off water. Two, to remove any volatile impurities, including water. If there's any selenous acid present, it dehydrates at 70 degrees, so it'll end up as selenium dioxide. Selenium dioxide completely sublimates at 315 degrees, so I cranked up the heat on my hot plate to get it started. It worked, but to make sure the sublimation was as thorough as possible, I also heated it with my heat gun, gradually rotating the beaker until it turned a full 360 degrees. I put a watch glass on the beaker, put some glass wool in the beak, and weighed it down with a block of lead bismuth eutectic. This is just what I had lying around. Once no residue remained on the bottom of the beaker, I figured the sublimation was done. The yellowish-green vapor is selenium dioxide in vapor form, not to be confused with the brown-colored vapors of nitrogen dioxide. I was initially worried that not all of the nitric acid had been removed previously until I double-checked and saw that the vapors are supposed to be that color. I put the beaker back in the paint can to let it cool. It worked so well. I am surprised that the beaker didn't break from being heated so strongly. One thing to note. Selenium dioxide is extremely sensitive to reduction by fucking everything, and it will react with dust, which is why impure samples are pink. They're contaminated with red metallic selenium. I, however, am a super amazing pro MLG chemist, so this shit is snow white. Here is a breakdown of yields and a couple things to note. Pause to read if you want. On to the bluing solutions. Here's a cropped screen grab of Super Blue's composition. We basically only care about the chemical names and what I circled. I used the averages of the upper and lower limits for everything other than water, for example, 2% for a range of 1 to 3%. I wasn't super worried if I was off 100 milligrams or so when weighing out the compounds because the weights would still fall within the ranges given in the composition section. Ignore how dirty my lab bench is, you'll see why in a future video. I'm doing multiple dirty iterations of the same thing for that video, so cleaning it is pointless until after the last one. As I'm recording this audio, I still have 2 to go, but I have done 3. I don't think the order of addition of the compounds matters, but just in case, I added the overly sensitive selenium dioxide last. I did have to heat up the solution a little bit to get the copper phosphate to fully dissolve, and it stayed dissolved when it cooled down. Using my gigantic brain, I wung it, whatever, when first trying out the pseudo Super Blue and did it wrong. Note the color of the solution here, before, and after. After winging it, I read the instructions for Super Blue and watched a few videos, and realized I had essentially fucked this whole batch. Rather than make another one, I worked fast to use it properly before it became completely unusable. Apparently, you're supposed to either apply it with a brush or preferably a Q-tip or some kind of cotton applicator, or you're supposed to take out just enough of the solution for what you're going to use it for and not return that to the original container. Oops. I don't own any guns. Hate to break the American stereotypes, I'm sorry. So I used the leftover part of a steel flat I have, some flathead screws, and a carriage bolt to test the bluing solutions. The screws and bolts were from a miscellaneous pile. I chose the ones where you could easily see the bluing and where there's a smooth surface. The carriage bolt was galvanized, so I removed that with some dilute hydrochloric acid. I removed the rust from this first flathead screw with hydrochloric acid as well, but I really should have sonicated it with it, as there was still some rust left when I applied the cold bluing. I blued the carriage bolt 4 times and the flathead screw once, using 3-in-1 oil on them afterwards. I let them absorb the oil overnight before wiping off the excess, and I will show the steel flat later. From what I've watched and read, Super Blue isn't a very good cold bluing solution. I don't have the commercial product, so I can't do a side-by-side comparison, but I hope that those of you that are watching this have used it and can see how it compares. I highly recommend drawing your own conclusions based on what you see, because I have no practical knowledge on this subject. If you want to, watch me mess with this bolt and screw, otherwise skip to the time on the screen for Oxpho Blue. Some math had to be done for this one too. I dissolved the copper sulfate in water and filtered it through a small cotton plug to remove the insoluble impurities, washing it a few times with water. The nickel sulfate hexahydrate has mostly written on it because it was dried in front of my space heater, and I think a small amount of it was dehydrated in the process. Here's what it looks like with everything dissolved. I didn't have to heat it like with the Super Blue. Here's what the Super Blue looks like after a day or two. I'll put it on the screen. It started blue, turned greener, and then is blue again, a white precipitate having formed. I'm not sure what the precipitate is. This time around, I put the screws in dilute acetic acid. I added glacial acetic acid to water arbitrarily overnight, sonicated them for 30 minutes the next morning, rinsed them off, and sonicated them with dilute hydrochloric acid until nearly all the rust had been removed. Oxpho Blue's directions say that it's okay for there to be a small amount of rust on what's being blued. I used steel wool on the untreated side of the flat until the bare metal was exposed. I probably should have done the same for the other side that was treated with pseudo super blue. To treat the screw, I put it in a test tube and pipetted pseudo Oxpho Blue into it until it was fully submerged. This screw I treated 3 times. The directions say to burnish it with steel wool 4-knot after bluing, but doing that for a screw seemed dumb, so I didn't. And you can see how quickly the solution changes, at least with this, in the test tube. For the flat, I did burnish it with steel wool after the first coat, but not after the second. I oiled both the screw and flat with 3-in-1 oil like the pseudo super blued stuff. Alright, time for testing. The oilier looking screw is the 3 times pseudo Oxpho Blued one. The other one is the 1 time pseudo super blued one. This isn't a fair comparison as they weren't blued the same number of times, or I guess same length of time, but I figured it would be better to compare two of the same screws rather than a previously galvanized carriage bolt and a non-previously galvanized screw. Watch me mess with them, use steel wool on them, and scrape them with a knife if you want. After that, I did the same thing with the steel flat. The side with the slightly upturned end that I wipe oil off of is the pseudo Oxpho Blue side. If you don't want to watch this part, skip to the time on the screen for a cost analysis. This was more of a proof of concept video than anything. I hope to get some feedback on this because I just don't have that much practical experience on this topic. And to the people watching this with more knowledge about cold bluing than me, should I make a bunch more pseudo super blue and pseudo Oxpho Blue in, like, I don't know, smaller volumes of like maybe 10 milliliters, varying the amounts of the components within the ranges given in the composition tables, seeing if the bluing is different, and if it is, how so? What's a better way to test the finish? Are there any other brands of cold bluing solutions I should try to recreate? I think another popular one is 4440, and that one seems a lot simpler. It doesn't have any selenium dioxide in it, which seems odd for a cold bluing solution. But again, let me know in the comments. And that's about all I've got. Thank you for watching. If you enjoyed the video, like, comment, and/or subscribe. I really appreciate it. It helps me out. See you in the next video.